All right, hello guys. We're going to go on ahead and I'm going to work through some of the even problems with you guys. Remember we did the odds in class, so I'm going to go through the evens so we can make sure that we understand how to work everything out for our test tomorrow. So remember, in order to get the extra credit for your review, you need to have all work shown on all problems and all problems completed. If it's not all work shown, not all problems completed, then you will not get extra credit. So the first one we're going to do is number 2. So what we have to do, if my screen will cooperate here, okay. What we got to do is determine if these 3 side lengths can be a triangle. So we take the small one and the medium one and add them together. So 6 plus 8, and that's 14. And you compare it to the longest side, which is also 14. Since they are equal, this is not a triangle. All right, now I'll do number 4 here. You take your small and your medium, so it's 4 and 9. So 9 plus 4. That's 13, and you compare it to 12. 13 is bigger than 12. Since the 2 you added are greater than the third one, this is a triangle. Okay. All right, now number 6. It says find the range for the measure of the third side of a triangle given the measures of 2 sides. So we have 32 and 61. So to find our max, we add them. So 61 and 32. So that's 3, and 6 and 3 make 9. So 93 is your maximum. And then now to find the minimum, we take 61 and we subtract 32 from it. Remember, it's always the big minus the small. So we borrow, 11 minus 2 is 9, and 5 minus 3 is 2. So 29 is our minimum. So our third side has to be between 29 and 93. All right, and then we did number 7 in class. Number 8 is very similar to it. So number 8 here, it says the measure of angle Y is 120. The measure of angle Z is 43. Okay, now we have to name the longest side of the triangle. So first we need to figure out this angle here because we need to know all 3 angles. So 120, and then we add the 43. So that's 163, and now 180 because all 3 have to be 180 together. So we subtract the 2 that we know. So 7 minus 6 is 1. So our other angle here is 17. Now your longest side is across from your largest angle. Okay, so find your largest angle. That's 120. Okay, go directly across from it. It's this side. That side is XZ. Okay, these ones, 9 through 11, these are in that multicolored foldable that has all these names on it. Okay, and I drew some pictures of some of them in class too, so kind of look at those. So BD. BD is right here. We see the right angle. So these 2 things that deal with right angles are either altitude or perpendicular bisector. So you really, you need to eliminate perpendicular bisector, and then you can say it's an altitude. So perpendicular bisector, we have the perpendicular part that's at the right angle. Okay, altitudes are also at right angles. Now let's look at the bisector part. So bisector, we have to look at this line, AC. Is AD congruent to DC? No. So it is not a bisector. So our only choice is altitude for BD. All right, now number 12. It says P is the centroid of triangle LMN. If QN, okay, is 9, what is the length of PN? So remember, we've got our line here, okay, and this is the same is true for any median, okay? So we have N, then we have P, and then we have Q. And notice how P is not right in the middle. Okay, if you look on your picture, PN, that's the longer part. So that's 2/3 of the entire line. So then PQ is 1/3 of the entire line, okay? And then now you got to look at the ratio of PN to PQ. Guys, 2/3 is twice the size of 1/3. So Pn is 2 times the size of PQ. So Pn is 2 times PQ. All right, Pn is twice the size of PQ because 2/3 is twice as big as 1/3. So now let's go label here. It says we have Qn is 9, and we want to know what Pn is. Okay, so first you should try to find QP. QP, or PQ, it's 1/3 of the whole line. So QP is Qn, because it's the whole line, divided by 3, because it's 1/3. So 9 divided by 3. And so QP is 3. So that's the small part. Now, like we said here, Pn is twice the length of PQ. So if we know this is 3, well, this one, what's twice of that? Okay, Pn is 2 times QP. So 2 times 3, which is 6. So Pn is 6. All right, next one, number 14. It says that BD is a median. Remember, a median starts at a corner and it bisects its opposite sides. So x plus 3 is congruent to 2x minus 17. So they are equal. So x plus 3 equals 2x minus 17. So now what we do is solve for x. So minus x here, minus x. 3 is equal to x minus 17. Okay, add 17, add 17. So 20 is equal to x. So 20 is x. Now we want AD. So AD is from A to D here. So x plus 3. So instead of x, we're going to put 20. And then we're going to add 3. So that's 23. So AD is 23. All right. We already did 15 in class. Okay, now 16. It says M is the midpoint of segment DG for the points D37 and G55. We want to find the length of MG. So I'm going to draw a picture here just to remind us. DG, that's the whole line. M is the midpoint. It's exactly in the middle. So DM is 1/2 of DG. MG is 1/2 of DG. So what we're going to do is we're going to find the length of DG and then cut it in half. Because if we do DG divided by 2, we can get MG. So first thing, we need to take D and G, and we've got to plot them. So D is at 3,7 and G is at 5,5. So go to our graph paper. Okay, draw your axes. Okay, so D is 3,7, G is 5,5. So 3,7 over 1, 2, 3, and up 1, 2, 3, 4, 5, 6, 7. So that's D. Okay. Yeah, 3,7, and then 5,5 is G. So over 1, 2, 3, 4, 5, and up 1, 2, 3, 4, 5. So that's G. Okay, and then you should draw your line. Remember, use your straight edge to help you draw your line. Okay, and now in order to find the distance, we're going to draw our little triangle. So I'll do this in a different color. So here's this one, and this one. So now count the sides. This one is 2, and this one is also 2. So 2 and 2. That's our A, and that's our B. And now we're going to use the Pythagorean Theorem. Remember, you have your right triangle here, okay? There's A, and there's B, and there's C. So C squared is A squared plus B squared. Well, we want to know the length of C because that's DG here. So C is the square root of A squared plus B squared. So that's what we're doing with these two sides of the triangle. One of them can be A, one of them can be B. So, but they're both the same in this case. So let's go back here. So DG is the square root of 2 squared plus 2 squared. So it's the square root of 4 plus 4, which is the square root of 8. Okay, now 8, if you try to take the square root of it, it does not come out evenly. So what you got to do is factor this. And so 8, if you factor it on the calculators, you'll get 2 cubed, which is really, well, 4 times 2, right? Okay, 4 times 2. And 4 is really 2 squared. So do you see how this 2 has a squared on it, but this one does not? Okay, only this 2 comes out. So we get 2 square roots of 2. So that's DG. And so now MG is DG divided by 2. So that's what we do. 2 square roots of 2 divided by 2. We have 2 times the square root of 2, and we're dividing it by 2. Those cancel. So mg is the square root of 2. Okay? Let me explain this one a little bit here. On your calculator, if you do the square root of 8, you're going to factor it, and you'll get 2 cubed. Okay? 2 cubed, because we're trying to do the square root, so we have to get this in terms of squareds. So 3 is made up of 2 plus 1. So this is really 2 squared times 2. Okay, because this is 2 to the 1. All right? So 2 squared times 2. So that's why only this 1, 2 gets pulled to the outside. So it's 2 square roots of 2. And again, on the test, you're not going to really have anything that complicated. All right, now let's look at number 18. It says the vertices of triangle RST are R, -5, -4, S, 4, 8, and T, -7, 9. Give the coordinate that is 1/3 of the distance from R to S. So we're going to start at R and go to S. We don't even need point T, so don't worry about it. So R is at -5, -4. So right here, there's R. And then S is at 4, 8. So go over 4 and up 8. So there's S. And then now use your straight edge. When you're trying to find the fractional distance, your line needs to be very accurate. So there's R and S. Can use our straight edge. There we go. Okay, and draw that line. And so now we're going to draw the triangles. So here's one side of it. And there's the other side. And so now we count the length of these sides. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is 12. Okay, and then here 1, 2, 3, 4, 5, 6, 7, 8, 9. And this is 9. Okay, that's 12 and 9. And so now it says we're going to find 1/3 of the distance. So we're going to do our change in X and our change in Y. Remember, X is left and right. Y is up and down. Okay, so now let's look at X. We're going to do 1/3 times, now what's the one that's going horizontally? 9. So 1/3 times 9 is 3. Okay, now we do the same thing for Y. 1/3, now the vertical one is 12. So 1/3 times 12 is 4. And so now we're going to start at R, and we're going to go towards S. So we're going to the right and we're going up. So we go 3 to the right, so 1, 2, 3, and then 4 up. 1, 2, 3, 4. You see how we land on our line there? Okay, you're looking right at the intersection there. So this point, look at the X, we go over to -2, and then the Y, we don't go up at all, so it's 0. So -2, 0. Okay, now number 20. It says find the midpoint of the following points. So we've got our 2 coordinates here. You take, for your x's, you take the x's and you add them. So -9 plus -1, and you put that over 2. So -9 plus -1 is -10 over 2, and that's going to be -5, so that's our x-coordinate. Now for the y, you got to take your y's. So 8 plus -7, and that's divided by 2. So 8 plus -7, that's 1. You got it over 2, so that's just 1/2. So that's your y. So your midpoint for this is at -5, 1/2. Okay, or you can change it to -5.5, 0.5. Okay, they're the same thing. Same thing. All right, now number 22, to find the distance of between the following points. Okay, you can use the distance formula. So remember, the distance formula is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Or you can do the Pythagorean Theorem thing where we get the triangle, so the square root of a squared plus b squared. Okay, so you have either or. So I'm going to do it through the graph because on the distance formula, all you're doing is here's x1 and y1, there's x2 and y2. You're going to get the same answer no matter which way you do it. So let's just do the graph because that seems to be easier. So -9, 8. Okay, so -1, 2, 3, 4, 5, 6, 7, 8, 9, and then we go up 1, 2, 3, 4, 5, 6, 7, 8. So there's -9, 8. And then we have -1, -7. So -1 and down 1, 2, 3, 4, 5, 6, 7. Plus -1, -7. Okay, and then now you'll use your straight edge and you draw your line. Okay, and now we need to draw the triangle so we can figure out the different sides of the triangle, so the A and the B. Okay, so there's one side, there's our other side, and now you count. So 1, 2, 3, 4, 5, 6, 7, 8. So our bottom side is 8. Okay, now do the vertical one. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Did I count that right? 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Let me see here. Yep, it should be 15. Okay, so there's 15. Okay, so now what we got to do, that'll be your A, and that will be B. Okay, so take your distance here. Distance is equal to the square root. And I said A is 15, so 15 squared plus, and then B was the 8, so 8 squared. So that's the square root of 225 plus 64. So that's the square root of 289. All right, and then if you try that in your calculator, so control and then the x squared and put 289, you get 17. So this one comes out evenly. So the distance is 17, the square root of 17. So always try the square root first. Then if it doesn't come out evenly like this one, that's when you do the factoring. Okay, so that's all there is to it, guys. If you're doing the fractional distance, you're drawing the triangles and counting. If you're trying to find the distance between points, you're putting the triangles on the graph, counting, and then putting them into this new formula that I've shown you guys. So I've given you multiple ways to do several of these problems. So go on ahead and make sure you Go over these ones, go over the ones we did in class, and you'll be good to go. All right, see you guys tomorrow. Good luck.